Okay, so I've been having some questions about some of the problems on the vector exam. So I'm going to try and clarify things a little bit. So let's say we have our x and y axis, right? So this will be the x direction, this is the y direction, and then we have some vector v. Okay. This is typically the situation we're looking at, where we had a vector v, and then we had some angle theta, and we calculated what the components of v are. But let's switch it up just a little bit, and let's make v point down instead of out. So we still have a vector v, we have an angle theta. So how does this change things? Well, let's look at what the components of v would be. So now we have our vy that points down, and we have a vx that points to the left. Right, so this has changed things slightly. So now if we write vx, right, now it's still, we have the magnitude of v times the cosine of theta, but now it's negative, right? We're pointing in the negative direction. And the same thing for y. You know, we have our vy, and it's minus the magnitude of v times the sine of theta, right? So we see that in this case it has the opposite sign. You know, as if the v was, as if it was pointing out, but of course in this case we know it should be, right? I've basically just written minus v from what I had before. But there's some other kind of non-standard, you know, vectors that you'll see. So for example, what if we'll draw v going out again, but now what if we call this theta, right? This isn't really that non-standard, it's just something that you haven't really seen before or thought about. So in this case, we have our vx and our vy, but we see that we can't just blindly apply trig functions, because for example vx is the magnitude of v, but now look, in this case it's actually sine of theta, not cosine, whereas vy is the magnitude of v cosine theta now, right? Because this is the adjacent angle. You know, there was some questions about this. So remember, we say that you know, the cosine of theta is the adjacent, which is vy, over the hypotenuse, which is the magnitude of v, right? So vy is v times cosine theta. Let's see, we can look at some other non-standard vectors. This is one that I think that was throwing a lot of people off today, so this is a good one to look at. So we'll set up our x and y, and now let's say we have v down here, and let's say we call this theta. So now we have an angle that's bigger than 90 degrees. Okay? This can actually be really confusing. So instead, what we can do is this same v, because theta is just some arbitrary angle. We don't know what theta is, right? All we know about theta is we know, in this case, that theta is greater than 90 degrees, but less than 180 degrees, right? If it was, because 180 degrees is at this point right here. Is along that line. Excuse me. Okay, so we know that it's somewhere between 90 and 180. So what we do is we actually think about v as being in this same quadrant. So we choose our angle theta to be less than 90 degrees. And when we do that, Now we see it's much easier to see Vx is the magnitude of V sine theta, just like we saw before, right? It's this component. And Vy is V cosine theta, just like in the last case, right? Vy is this component. So it's actually the same exact answer as we had before. But that may seem puzzling to you because it's actually the actual Vx we have, right, is this right here, and this is our Vy. So, we see in this case we have a Vy that's negative. So how does that happen? So I want you to think about that for a second. So I want you to pause the video and take a couple minutes and just see if you can figure out why what I've said, why these formulas are true, but why it's consistent with having this Vy that's negative. So go ahead and pause the video now. Okay. So here's what we do. We have to remember something about our trig functions. So remember that if we have sine of theta, okay, let's say this is our x and y axis, and this is theta. So if theta is between 0 and 90 degrees, sine of theta is positive. If it's between 90 degrees and 180 degrees, sine of theta is still positive. If it's greater than 180 degrees, sine theta is negative. Now let's look at our cosine function. So for the cosine, again, if it's between 0 and 90, it's positive. But for the cosine, if it's between 90 and 180, it's negative. If it's between 180 and 270, it's still negative. But then between 270 and 0, it's positive again. So you see in this case where we have a theta that's between 90 and 180, that's giving us this range here. So that means that in this case, for our theta, it's actually this cosine term that's negative. And that's where the negative sign on the vector comes from. So everything that we said is self-consistent. And if this is your first time seeing this, or if you haven't seen this since like trigonometry in like 9th or 10th grade, you may not remember this. So this is a good time to kind of sit down and like pay attention to triangles and pay attention to these trig functions and see what everything really means. Because I can't stress enough how important understanding these concepts are later in this class. Most of the people that I see, making C's and D's and F's in their freshman physics are doing so because, they're worrying so much, on the physics that comes later, and they don't understand these very fundamental things about vectors that are so important.